trigonometric equations and solution of triangles. Trigonometric formulae. In this module, at first we will introduce the basic trigonometric functions. Then we will learn about the angles, trigonometric functions of sum and difference of two angles. At the end, we will summarize all the concepts discussed in this module. The word trigonometry is derived from the Greek word trignon and metron. The word trignon means a triangle, and the word metron means to measure. Hence, trigonometry means the science of measuring triangles. In the previous module, we studied about the trigonometric identities and application of the trigonometric ratios in solving the problems related to heights and distances. Angle is a figure obtained by rotating a given. If the direction of rotate, let us study about degree measure. If the initial side of the angle is rotated to the terminal side by the 1/360th part of a revolution, then the angle is said to have a measure of 1 degree. When a degree is divided into 60 equal parts, each part is then called a minute. Similarly, when a minute is divided into 60 equal parts, each part is then called a second. We use the shown notations for degree measures 1 minute and 1 second. Here are some examples when the angle is measured. Here are some examples. Which of the following is the correct degree measure representation of an angle of 45 and 2/3 degrees? 45 degrees and 20 minutes, 45 degrees and 40 minutes, 45 degrees and 30 minutes, or 45 degrees and 50 minutes.
So you tell me 45 degrees and 20 minutes. Why is it 20 minutes? 45 degrees and 20 minutes. 40 minutes. How? What is the reason? So you know how to convert, right? So now we are also going to learn about one more kind of angle measurement, which is called the radian measure. What is the definition of radian measure? How do you define a radian? Suppose L is let A, B, and R. Let L be the length of the R, and let OB equal to OA be the radius, let R be the radius. Then what is theta in radians? Okay, but suppose we imagine this is sweeping the entire circle, then we know it covers an angle of 360 degrees. So, how will 360 degrees correspond to radians? So, in radians, what does it correspond to? So, that is a question we are going to ask now. So, what does it correspond to? How? Because when you say 360 degrees, you are covering the entire circle. The circumference of the circle is 2 pi r. So, the same definition, length of the arc is 2 pi r. Divide by the radius to get 2 pi. So, 2 pi radians corresponds to 360 degrees. You all understand what is the definition of a radian? Now let us test your understanding. What is pi by 4 radians? What is pi by 4 radians? Okay. What is 90 degrees in terms of radians? What is 2 pi by 3 radians in terms of degrees? Pi by 3 is 60 degrees. So 2 pi by 3 will correspond to 120 degrees. Okay. So what will be 5 pi by 4 radians correspond to? What does 5 pi by 4 radians correspond to?
Radian.
Pi by 4
We
is
know how to measure an angle
5
in
by
degree.
4 is 45 degrees.
However, there are other ways of measuring an angle too. One such way is to measure the angle in radian. In scientific and engineering calculations, the usage of radians is more prominent than degrees. Do you know the meaning of angle 1 radian? Let us find out. Consider a circle with center O and radius R. Now draw two line segments, OA and OB, representing the radius of the circle, such that the length of the arc AB is equal to the radius of the circle. The angle AOB so formed is called the angle of 1 radian. Thus, in a circle of radius r, an arc of length r subtends an angle of 1 radian at the center of the circle.
Here is an example of angle 1:1 by 2 radians measured, when the angle is measured clockwise and anti-clockwise.
If theta in radians is the angle subtended at the center of the circle of radius r by an arc of length L, then theta is equal to L upon r, or L is equal to r theta. Consider the unit circle with center O. Let A be any point of the circle. Consider OA as the initial side of an angle. Then the length of an arc of the circle will give the radian measure of the angle, which the arc will subtend at the center of the circle. Consider the line PAQ, which is tangent to the circle at A. Let the point A represents the real number 0, AP represents the positive real number, and AQ represents the negative real number. If we route the line AB in the anti-clockwise direction along the circle and AQ in the clockwise direction, then every real number will correspond to a radian measure, and conversely.
Do you understand the connection?
Thus, radian measures and real numbers can be considered as one and the same.
Are you able to understand how the radian measure will correspond to a real number? Because if you take this to be 1 unit, if you move this side, then you are moving in which direction? If you move like this, clockwise direction. So that is what your positive numbers and negative numbers are all about. So if you take a radius to be 1 unit, then if you move it in the anti-clockwise direction, then it can be mapped down to positive. If you move it in the clockwise direction, it will be mapped down to negative number. So radian measures can be considered to be having one-to-one correspondence with real numbers. This is just one way of looking at radian measure in connection with real numbers.
Circumference of the circle is equal to 2 pi r in radian measure. The angle subtended by the circle at the center is equal to 2 pi radian in degree measure, The angle subtended by the circle at the center is equal to 360 degrees. Therefore, 2 pi radians is equal to 360 degrees, or pi radian is equal to 180 degrees. Using the value of pi, we get 1 radian is equal to 180 degrees upon pi, which is equal to 57 degrees, 16 minutes approximately. Also, 1 degree is equal to pi upon 180 radian, which is equal to 0.01746 approximately.
Now pi is a irrational number, whereas 22 by 7 is a it's a rational number. Any number of the form p by q, where q is not equal to 0, it's a rational number. So why do we say pi is 22 by 7? Is pi 22 by 7? So pi is an irrational number. So for our purposes of calculation, we look at its approximate value. So please remember pi is not 22 by 7, because 22 by 7 is a rational number as opposed to pi, which is an irrational number. So we only for the purpose of solving sums make estimates, right? When you do heights and distances, you have to make estimates of heights, of distances. Then you need to use an approximate value. So 22 by 7 or 3.14 are all approximate values of pi.
Note that when an angle is expressed in radian, the word radian is frequently omitted. For example, we know that pi is equal to 180 degrees and pi by 3 is equal to 60 degrees. Hence, they are written without using the word radian.
So this is notation, right?
Here we see the formula which converts a radian measure of an angle into a degree measure of an angle. We also have the formula which converts a degree measure of an angle into a radian measure of an angle. Let us now see some common degree and radian measures.
We have seen some conversions. Already you have converted.
Here we have the degree and radian measure of some common angles such as 30, 45, 60, 90, 180, 270 and 360 degrees. Let us now solve some examples related to the degree and radian measure of an angle. Express the angle 35 degrees and 15 minutes in radians. Solution. We know that 60 minutes is equal to 1 degree. Hence, 1 minute is equal to 1 by 60 part of a degree, or 15 minutes is equal to 1/4 of a degree. Hence, 35 degrees and 15 minutes can be written as 35 and 1 by 4 degrees.
Already familiar with this conversion, so just see whether you understand, and one of you explain, and one of you get up and explain this. How do we get this? What does this say? 1 degree equal to 60 minutes. So therefore 1 minute will be equal to 1 by 60 degrees. So we have 15 minutes. So 15 it will be equal to 15 minutes will be equal to how many degrees? That's the question we are asking. So 15 into 1 by 60. So we get 35 1 by 4 degrees.
Now we know that 180 degrees is equal to pi radians, or 1 degree is equal to pi upon 180 radian. Hence, 35 and 1 by 4 degrees can be expressed in radian measure in the following way, and is equal to 47 pi upon 240 radian.
Make a note of this. So what do we do now? 35 1 by 4 degrees we are converting to radians.
Let us find the correct answer for the given question. By solution. Consider a unit circle with center at the origin of the coordinate axis. Let A with coordinates AB be any point on the circle with angle AOB is equal to x radian. That is, length of arc AB is equal to x.
So also studying trigonometric functions. Let's recap. This is a recap.
Since one complete revolution subtends an angle of 2 pi radian at the center of the circle, angle POQ is equal to pi upon 2. Angle POR is equal to pi and reflex angle POS is equal to 3 pi upon 2.
See, angle POQ is 90 degrees, which is pi by 2 radians. And what is reflex POS? What is POS? If I say reflex, then you are looking at the remaining angle, right? What is that angle? Reflex angle. Which is 270 degrees.
All the angles, which are the integral multiples of pi upon 2, are called quadrantal angles. Here, cos x is equal to A and sin x is equal to B.
Imagine this is a radius as if it is sweeping from the x-axis. At one point, let us suppose it was perpendicular to the x-axis, then it keeps on moving and it actually covers the entire circle. Then if I draw a vertical line here, let me call this point as B, this point as C, and this angle as theta. Then you know that sin theta what? BC by OB. It's the opposite side, which I am calling it as R. Or if I take R to be 1, it is BC by R. If I take R to be 1, then BC equal to sin theta. Okay. Then what will be cos theta? OC by OB. If I take R to be 1, cos theta equal to OC. Right? Now, if I look at any point on the circle, if I take any point, I can write its coordinates as x comma y in Cartesian form. Right? So, suppose I consider a unit circle. What do you mean by x comma y? If I draw the perpendicular from P and call this as say M, then OM will represent the x coordinate. PM will represent the y coordinate. So the horizontal distance represents the x coordinate, the vertical distance represents the y coordinate. This is you are already familiar with this. This is representation using Cartesian coordinates. But if the same thing, if I take this angle to be theta, then I can represent it what? What we suppose I call this as some x comma y. Then what is the x comma y? Cos theta, sin theta. So every point on the unit circle can be uniquely expressed as cos theta, sin theta. So one way of looking at it is in terms of Cartesian system, which is your x comma y. Another system which is called as the polar coordinates is through the angle through which the radius describes as it moves around the unit circle. Using polar coordinates, we call this as polar coordinates. Every point can be written as cos theta, sin theta. Make a note of this. Every point in the unit circle can be expressed theta is 90. What will be this point? Cos 90, sin 90. What is that?
The coordinates of the points P, Q, R and S are respectively 10, 0, 1, minus 1, 0 and 0, minus 1.
Have you learned the values of 180?